Hello out there, you are welcome to DaveTuts Academy, where we are devoted to building excellence in students, especially when it comes to the basics of the STEM subjects. Our video today is going to be a walkthrough of all the questions from the WAEC Private Candidate 2021 November exam, which is popularly regarded as the GCSE exam. And we are going to take our time to solve all of the 13 questions from the mathematics theory paper, and feature a whole lot of topics like number base, word problems, sequences and series, fractions, triangles, coordinate geometry, mensuration, circle theorem, statistics, probability, and a whole lot more. So if you are preparing for your O-level exams, talk about your WAEC, NECO, GCSE, GED, IGCSE, you are going to find this very, very useful because we took our time to demystify all of these questions and also explain the reason behind the steps that we are taking. You're going to get a whole lot of tips on how you can use a calculator to simplify your work. So let's just get set, get ready, get your pen, get your biro, get your pencil, get your calculator, get your paper. Let's walk along together. It is as you do that that you're going to build that excellence that you are looking for. And if you are here to subscribe, why not just go ahead and just click on the subscription icon and also click on the notification bell so that anytime our video is available like this, you are going to get notified and it will enhance you on that path to excellence. Our work is cut out for us. Let's just go ahead and delve into our video for today. In this question on sequence and series, we are told that a sequence of numbers is defined by a subscript n plus 1 is 2a subscript n minus 3, where n is greater than or equal to 1. Now, if a1 is 5, we are to find a2, a3, and a4. Now, from here, originally we are giving an plus 1 is 2an minus 3. And then if you are to look at it, we already supplied with the value of a1 the first time that it is 5. So if we want to use that in this equation, we can get a2 to say, in this case, a2 will be, now that n is 1, we are adding another 1 to it. That is what is giving us a2. So if we have 2an, then n is 1. So we have 2a1 minus 3, okay? And that will give us, a1 is 5, so we have 2 times 5 minus 3, and that is 2 times 5 is 10. 10 minus 3 is nothing but 7. So that is the very first mandate before us, and we have scaled it successfully. A3 will now be 2a2 again minus 3, and if we are to just continue in that model, a2 will go to be 7, then minus 3. This will be 2 times 7 is 14. 14 minus 3, that will be 11. So yeah, you need to be careful that you don't miss any step because you are going to use that value in the next operation. So here we can say a4 is now going to be 2a3 minus 3, and that will be 2 times, what is a3? That is 11 minus 3. 2 times 11 is 22. 22 minus 3, that will be 19. Okay, and with that, all we are asked to find, a2 we got as 7, a3 we got as 11, a4 we got as 19. We've done that and our work is done and dusted. All right. In these beautiful questions on fractions, we are told that the student had an account of P Ghanaian cedis at the beginning of a semester. Now he spent 1/3 of the amount on books and 3/5 of the remainder on snacks. If 100 Ghanaian cedis was left at the end of the semester, we are to find the value of the original amount of money that he had in Ghanaian cedis. So this is a very good question. We just take each of the sentence, each of the statements, try to interpret it, and then see how that can help us to solve this question. So originally, what he had was P. The original amount that this student had was P. Okay, now when he spent 1/3 on books, we can say books will be 1/3P. Okay, and then if books is 1/3P, we can say that the remaining after the books will now be P minus 1/3P is P/3. Okay, so this is going to be 2P/3. Okay, because if we say we want to look for the LCM, we can just say we have this like 3, then this is like P/1, so that this will be 3P minus 3 can cut 3, just 1, then this will be minus P. So inherently, what we have is 2P/3 as the remainder after he had deducted the money for the books. And then we are now told that furthermore, he spent 3/5 of the remainder on snacks. So this is that remainder, and we need to look at 3/5 of this remainder to get the amount he spent on snacks. So if that is the case, we can now say that snacks snacks will amount to 3 over 5 of this remainder, which you got to be 2p over 3. Okay, so this is the consistency we need to ensure that we get our question right and dusted. We can see that those 3 will cut out, and then the snacks will be 2p over 5. Okay, now we're told that 400 Ghanaian cedis was left at the end of the semester. Okay, so if this is the original amount, he spent this fraction on books and he spent the fraction on snacks, the total remainder, which we are being told is equal to 400 Ghanaian cedis, will be the original p minus first the amount he spent on books, that is p over 3, plus the amount he spent on snacks, that is 2p over 5. I hope this is clear enough. I hope this is simplified enough, because once we get this, then we know that we are good to go. Yeah, we can say we want to look at this holistically. Let's just say we are finding the LCM 3 and 5, that will give us 15. So this p will be 15p minus, this is where we need to be careful. This is the amount is spent on books and snacks, so it will still remain in that bracket. 15 divided by 3 is 5. 5 times p, that will be 5p. Then plus, now I'm putting plus because the negative sign is affecting the whole of this bracket. Okay, 15 divided by 5 is 3. 3 times 2p will be 6p. Okay, so that means this total remainder, what were we giving as? We are giving it at 400 Ghanaian cedis. So we can say 400 is equal to nothing but, now 5p plus 6p is 11. 15 minus 11, that will give us 4p over 15. So the p that we are looking for, if we cross multiply here, will be 400 multiplied by 15, and then to leave only p, we need to divide it by 4. Okay, so we can just cut, saying that here we can have 4 here, 1, 4 in 400 is 100, such that the value of p that we are looking for, which is the original amount, will be 100 times 15, and 100 times 15 is nothing but 1,500 Ghanaian cedis. So we have 1,500 Ghanaian cedis as the original amount that the student had in his account. Okay, in this question on word problem, we are told that two cars A and B, which are 180 kilometers apart, started the journey at the same time towards each other through the same route. Okay, now if the speed of A is x kilometers per hour and that of B is x minus 20 kilometers per hour, that means that A is traveling faster than B. Our mandate is to calculate the distance covered by each car just at where they meet after 90 minutes. Okay, so a picture is worth 1,000 words, and this is a pictorial view of what we are being told is happening in this particular case, that A is moving at x kilometers per hour, so this is x kilometer per hour. Then B is moving at a speed which is x minus 20 kilometer per hour, so we have that as given. So like I said initially, that means that A is traveling faster than B. So if they are meeting, they will meet closer to B. So let's say somewhere around there. So this may inherently be their meeting point. Now if we are to talk about the distance, if A, the car A will cover some distance, let's say this will cover distance A to their meeting point, that means that B will cover 180 minus A kilometers, because we have been told that the distance between them originally is 180 kilometers. So if A will cover A kilometers, okay, if I say this is A kilometers, B will cover 180 minus A kilometers, so that the addition of the two will just be 180 kilometers. So we have to get the distance covered by each car just at where they meet. So A will cover A kilometers, B will cover 180 minus A kilometers. Now we are giving one parameter, that the time is 90 minutes. So if I want to work with that, in the unit of the dimensions that we are giving, you can notice that we are giving kilometers per hour. So we need to take 90 minutes and take it to hour. And we know that 90 minutes, which is the time, that time is going to be 1 hour, 30 minutes, or I can say it is 1.5 hours, because 30 minutes is half of an hour. Inherently, I can say this is one whole number, 1 over 2. Or I can say this is 3 over 2 hours. Okay, so This is good because it can help us to solve this, because we know that normally speed is defined as distance over time, but here we have the time, we have the speed as a variable of unknown, we have the distance as a variable of unknown. So I can say time, which I know, can be distance over speed by changing the subject of formula in this particular case. Okay, so in that case I've gotten that time to be 3 over 2. I can say for A, the timing for A, which is 3 over 2, is that 3 over 2 is equal to, what is the distance for A? It is A, and what is the speed? That is x. And then for B, I have that same 3 over 2 is equal to, what is the distance for B? It is 180 minus A, and what is the speed for B? That will be x minus 20. Okay, so from here I can say I may just say I want to choose to cross multiply, so that I have it that 3x equal to 2a, and from there I can make anyone decide the formula as I will be needing in this case. Now for this second case, I can say here I just want to cross multiply, and for me to cross multiply like that, I will just have 3 into x minus 20 is equal to 2 into 180 minus a. So let's open up. This will be 3x minus 60 is equal to 2 times 180 is 360 minus 2a, and then here I can see that 3x minus 2a is equal to 360 plus 60. Okay, this is plus. If I add 2a to both sides, then if I add 60 to both sides, it's just like this. Now look at this. 3x is equal to 2a, or 2a is equal to 3x. So this is just inherently the same value. If I want to just solve for a, since a is what I'm looking for, I can say this 3x, yeah, it is 2a now. So I can say this is just 2a plus 2a is equal to 360 plus 60. That will be 420. So that I have 4a is equal to 420. Then a itself will be this over 4. Because I can see that this 4 can cut this 4. 4 here, this is 1. 4 in 400 is 100. 4 in 20 will be 105. So I can say the distance for car A, which is equal to A, is nothing but 105 kilometers. And already we have said the distance for car B, distance for B is what? It's giving us 180 minus A, and then that is from here. That A is 105. So the distance for the car B will be 180 minus 105, and that is 75 kilometers. So our understanding of the concept of speed, distance, and time had helped us to interpret this question correctly, and we got the distance of car A to be 105 kilometers, while the distance covered by car B is 75 kilometers. For this question on measuration of triangles, we are told that the perimeter of an equilateral triangle, so we need to understand what an equilateral triangle is, that is of side 14 centimeters, is the same as the perimeter of a triangle MNP. Now, if the length of the sides of triangle MNP are consecutive integers, we are to calculate the longest side of triangle MNP. So what is the meaning of the sides of triangle MNP being consecutive integers? That means they are numbers that sequentially follow each other. Is either we have 4, 5, 6, or 11, 12, 13, or 22, 23, 24, or something like that. They need to be consecutive. They need to follow each other. So if you want to look at this question, let's say we have this as a diagram, and in the first case we are told that it is an equilateral triangle. So if you call this triangle ABC, which is equilateral, each of the side is 14. That is the meaning of equilateral. The sides are equal, and of course the angles, they are also going to be equal. For the equilateral triangle, each of the angle is 60, so that 60 times 3 is 180. We are told that the perimeter of this triangle ABC is nothing but equal to the perimeter of this other triangle. Let's call this MNP. Okay, but now how do we get the perimeter of a triangle? It is the sum of all the sides of that triangle. So in this case it will be 14 plus 14 plus 14, or you can say it is 3 times 14, and that will be 42. So this is 42 centimeters. So this perimeter is the same as the perimeter of this triangle MNP. But now we are told that the sides of MNP are consecutive integers. So let's say x is the least side. So this is looking like the least. The next one will have to be x plus 1, and the longest one will have to be x plus 2. What we have to find is the longest side of MNP. So what we are looking for is x plus 2. So now if you want to look at the perimeter of triangle MNP, we just need to sum all the sides. That will be x plus the second side, x plus 1, plus the third side, that will be x plus 2. We are told that the perimeter of these two triangles are equal. So that means the sum of all this is 42. So that if we collect like terms, x is featuring in 3 places. We have 3x plus 1 plus 2, that is 3, is equal to 42. And then 3x will be 42 minus 3, and that will be 39. So that if we divide by 3, okay, we can just get the value of x to be 3 here 1, 3 here 13. So we can say from here x is nothing but 13. But note that nobody asks us to find x. We are asked to find the longest side. So we can just say from what we have seen so far, the longest side will be the higher of those consecutive numbers. That will be x plus 2, okay, and that will be 13 plus 2, which will give us nothing but 15 centimeters. So 15 centimeters is a solution to this particular question that we are given here. In this question on intercept theorem and parallel lines, we are told that the diagram features angle RPQ to be 32. So this is RPQ, that is 32 degrees. SNO is 90 degrees. SNO is a right angle here. And then NS, line NS is parallel to PR. So NS and PR, they are parallel. We have to find angle NOP. NOP, this is the angle of interest to us. That's what we are looking for in this particular question. Okay, good, fine, and wonderful. How best can we solve for this? You can actually make use of whatever means is suitable for you. But for me, I'm noticing that for this particular diagram, if I draw another parallel line from that point O, and you can see it's actually going parallel to these other two lines that are parallel. So I can say this is also parallel to them. This will help me to postulate the theorems that I know are applicable to parallel lines and the transversal between them. First, I can say that this angle here that I will just shade in this blue, that angle TOP is also going to be 32 degrees because comparing that to this, it is complementary to this angle. So I can say angle TOP is equal to angle RPQ, and that is also going to be 32 degrees because they are complementary angles. They are similar to one another, they are facing the same sides, they are complementary angles. Okay, so having gotten that, I can look at this particular side and say that this angle here, I can say this is going to be 90 degrees because that angle and SNO that we have, they are angles on a line. So I can say that angle MNS is equal to 180 minus angle SNO, and that's going to be 180 minus 90, which is 90 degrees. And why am I saying that? Because they are angles on a line, and the sum of angles on a line is actually 180 degrees. Okay, so that is MNS, but it's not only stopping there. I can also see NOT. So this NOT in blue also, angle NOT is also equal to angle MNS, and that will also be 90 degrees. Why? Again, they're also facing the same sides, and they're also cross with the transversal between two parallel lines. So I can say that is 90 because these are complementary angles. Okay, so having all of this now, why am I doing this? Because I'm seeing that angle NNOP that I'm looking for is comprising this NOT, which is 90, and this TOP, which is 32 degrees. So I can just say the angle I'm looking for, angle NOP, is equal to MNS that I got to be 90 plus angle TOP that I got to be 32. So that will be 90 plus 32, and 90 plus 32 is nothing but 122 degrees. So The understanding of the parallel lines that are crossed by a transversal had helped us to solve this question. You can also look for some other means. In short, just try it out. Look for so many other ways that you can also solve this question, and you see that inherently you will arrive at the same answer and the question would have been done and dusted. In this question on angle of elevation, we are told that a boy sitting on a tree at a point 12 meters above the ground observed that the angle of elevation of the top of a tower 60 meters away was 28 degrees. We have to find, correct to one decimal place, the height of the tower. So this is a very good pictorial view of what we are looking at in this particular case, and I will be overlaying the diagram of what we can do to actually get this done correctly as appropriate. Now this is the boy, and we are told that he is 12 meters above the ground. So we can say from his high level to the ground we are looking at 12 meters. So this is 12 meters. Now we are told that he's observing the top of a tower at an angle of elevation 28 degrees. That means from his point of perspective horizontally, he's now looking at the top of the tower, so that the angle of elevation here, this angle, is 28 degrees. Okay, and then the tower we are told is 60 meters away. So the distance between the boy and the tower, like here, we can say this is 60 meters. We have to find, correct to one decimal place, the height of the tower. So we can just say we want to finish up our diagram by completing that, and we can say we want to join it fully. So this is the diagram now. We are asked to find the height of the tower. So the height of the tower will be from the base of the ground to the top of the tower. So we can call it as h, and that h we will be able to look for it, saying that this is the distance from the top of the tower to the base of the tower. Now let me reduce the opacity of what we have at the base so that we can see our diagram straight and fine. If you are taking this side facing this angle 28, if you call this x, okay, we can see that h is nothing but the addition of this side, which is also 12 meters because it is parallel to the height of the tree. So we have this as also 12 meters. So h is nothing but 12 plus x, okay, and then we have been told the distance between the boy sitting on the tree and the tower to be 60 meters. So we have noted that before. So inherently we are seeing that for this question we have 12 meters, but we need to find x, and the addition of 12 and x will give us the height of the tower. Okay, so if we can solve that, we'll get this done and dusted, and that will really help us to solve this. Already considering angle 28 degrees, so if I want to take this point 28 degrees, we will see that the side facing 28 is this x, so that is inherently the opposite. So this is the opposite to x. Okay, this is the hypotenuse, and this 60 is the adjacent. So we have it that from SohCahToa can help us to solve this very wonderfully, because we know that we are looking for the opposite, but we have the adjacent. What trigonometric identity is relating the opposite and the adjacent? It is a tan, so that from here we can say tan 28 is equal to the opposite, which is x that we are looking for, over the adjacent, which is 60, so that our x will be 60 tan 28. So we can use our calculator to try and evaluate that. Okay, so we can say we are looking for 60 tan 28 in our calculator, and that is 31.9025, or let me just say 31.90. so this is 31.90 meters. Okay, but nobody asks us to find the value of x. What we are asked to find is the height of the tower. We can see that height of the tower, height of that tower, from what we have been able to deduce from our diagram, is nothing but 12 plus x. Therefore ht, which is the height of the tower, is 12 plus 31.9 meters. Okay, so that will be 43.9 meters. And oh good, we are even asked to find it correct to one decimal place. So in this particular case, 43.9 meters is going to be the value of the height of this tower as requested. In this question on a map, we are told that the scale of a map is 1:5000. Okay, now if the distance between 2 points on the map is 12 centimeters, now 1:5000, which one is smaller? We are looking at a map now, which you can look at on a paper. Definitely is going to take the smaller scale. So this is the map ratio, the real life scale. The map is the lower one, the real life is actually the larger one. So 1 is corresponding to the value we are going to have on the map. The real value is corresponding to 5000. Now I told that the distance between 2 points of the map is 12 centimeters. That means 12 centimeters is now relating to a particular value that we are looking for, which we can call, let's say it is x. All right, but now you should note that this x we are looking for will have to be also first in centimeters, but since we are asked to find it in meters, we need to eventually convert it to meters. So from here we can say we just want to cross multiply to say that x will be 12 multiplied by 5000. Okay, 12 multiplied by 5000 will be 60,000, but that 60,000 will be the unit in centimeters. So if we want to take it to meters, we can say x is going to be 60,000, we have centimeters, over 1. But then to take it to meters, we need to multiply by meters. How many centimeters make 1 meter? That is 100 centimeters. So this is just saying 1 meter over 1 meter, because 100 centimeters is 1 meter. And that will help us to take care of the centimeters, so that our answer will only be in meters. But then we are seeing these two zeros can cut them, so that the value between those 2 points, which we denoted as x, will be 600 meters in the real world. Okay. Here in this question on probability, we are told that a bag contains 24 identical balls, 8 of which are red, 6 are blue, and the rest are green. Now, if a ball is drawn at random from the bag, we have to find the probability that it is green, it is red or green, then it is not green. So let's look at the pictorial view of what our bag may look like, okay? And then if you are to look at how our selection can be made, already from the information that we are given, we are told that there are 8 red balls, 6 blue balls, and then the rest are green. For us to get the number of green, we are told that the total number of balls was 24. So the total balls is 24. Now if we find 8 red, 6 blue, then the number of greens, that number of green ball will be 24 minus the addition of 8 plus 6. Okay, that will be 24 minus 14, and that will be 10. So we can just append that green as 10. So this is what we have, and we need to look at this probability as requested of us. In the first case, we have to find the probability that a ball selected at random is green. That probability of picking green in the first question is going to be the number of green balls over the total number of balls. Okay, or let me just say n total. It will be the total number of balls. And what's the number of green? We got it to be 10 initially. The total number of balls were given as 24. If we cut out this, 2 can go in 10, that is 5. 2 in 24, that is 12. So that's the probability of picking a ball that is green. Okay, now let's be careful here. In the second case, if a ball is drawn at random from the bag, we have to find the probability that it is red or green. Okay, so just a singular ball, but now we're looking at probability of red or green, and that will be probability of red plus the probability of green. Okay, so this is what we need to note. And then if you want to do that, probability of red will be the number of red balls, which is 8 over 24. Okay, but the probability of green, that is 10 over 24. And since we didn't cut out, this will just be 18 over 24. And now for us to cut, think 6 can go in 18, that will be 3. 6 in 24, that will be 4. That is the probability of picking red or green. And then in the third case, what's the probability that the ball that will be picked is not green? So we are looking at probability of green prime. And since you are saying it is not green, that means it is the 1 minus probability of green. And to solve that, that will just be 1 minus what the probability of green that we got initially, 5 over 12, and this will be nothing but, you can say we want to find the LCM, it will be 12 minus 5, and that will give us 7 over 12 as the probability of picking a ball at random from the bag, but the ball is not green. And with that, we've solved this question and dusted it as appropriate. Okay, here's a question on binary operations, and here we are told that the operation asterisk is defined on the set R of real numbers by m asterisk n is half of m minus n. Now, if m is 2, n is 4, and p is 6, we have to evaluate. In the first case, let's do this. We have m asterisk n plus p, and if we want to put in those values, what is m? M will be 2 asterisk. We need to first carry out the operation in bracket. If you recall your board mass or PEMDAS, so we have n is 4 plus p, this is 6. So if you carry out the operation in bracket for, so we're having 2 asterisk 10 in this particular case, or we can just write 10 directly to say this is nothing but 2 asterisk 10. But we recollect that m asterisk n will be half of m minus n. So in this case, that's going to be 1 over 2. The first alphabet, which is relating to m, is actually 2. Then minus the second alphabet, which is relating to n. In this case, that will be 10. Alright, so we have 1 over 2 multiplied by 2 minus 10, that is minus 8. And then if you cut, minus 8 over 2 is minus 4. Alright, that's good and fine. In the second case, we have m asterisk n plus m asterisk p. So we have m asterisk n, we have to put that in bracket, so we evaluate that. Then m asterisk p. Again, if we are bringing in board mass, we need to do the operation in bracket first before we go on to the addition. Okay, so m is 2, so what we have here is inherently 2 asterisk n is 4 plus m, again m is 2 asterisk p, and p is 6. So if we want to do this now, we just want to carry out this binary operation. So we have 1 over 2, the first alphabet, 2 minus the second alphabet, which is 4, plus 1 over 2 into the first alphabet, 2 minus the second alphabet, which is 6. So this will give us 1 over 2 into minus 2 plus 1 over 2 into 2 minus 6 is minus 4. So we can just cut, and that will give us minus 1, okay, then plus minus 2. Here, negative sign and the positive sign will multiply to give a negative sign. So this will be minus 1 minus 2, which is nothing but minus 3. So these are the answers that they are requesting of us. And once you're able to get this, you are good and fine. Your full mark is assured, right? Okay, yes, this is a question on equations, particularly quadratic equations. Arguing that the root of the equation 2x squared plus m plus 1x plus n equal to 0 are 1 and 3, where m and n are constant. We have to find the values of m and n. Okay, so I think there are generally 2 means that you can go about trying to solve this. It may be more than that, but that I'm seeing and perceiving already. You can actually start to reverse engineer by saying the roots are 1 and 3. So x is 1 and x is 3. Then you take it back. So x minus 1 into bracket, x minus 3 is equal to 0, and you expand the bracket. You can do that, but that's not what I want to do. I want to actually simplify this to say this will become, dividing through by 2, I have s squared plus, look at this, m plus 1 over 2x plus n over 2 is equal to 0. So I just divide through by 2. Dividing by 2 is giving me this, okay? And so if I'm to compare with the general form of equation saying s squared minus alpha plus beta x plus alpha beta is equal to 0, where alpha plus beta is the sum of roots and alpha beta is the product of roots, then I'm to see that alpha plus beta, or inherently let me just say minus alpha plus beta, is equal to m plus 1 over 2, okay? And what is my alpha and beta? They are 1 and 3. In short, let me say alpha is 1 and let me say beta is 3. So from here, that means what I can have is that minus 1 plus 3 is equal to m plus 1 over 2. So this is 1 plus 3 is 4, minus 4 times 2. So I have minus 4 multiplied by 2 is m plus 1, so that I'm saying m plus 1 is equal to minus 8, and then m will be minus 8 minus 1, which will be minus 9, okay? And then the product of roots, I'm having alpha beta is equal to n over 2. Therefore, alpha is 1, beta is 3. I'm having 1 multiplied by 3 is equal to n over 2, such that n itself will be 3 times 1 is 3, 3 times 2 is 6. So you have 3 multiplied by 2, which is equal to 6. Okay, so this is what I would like to say is the solution. And then let me just show us this. The original equation will mean that we have 2x squared plus m plus 1. M plus 1 will be minus 9 plus 1 will be minus 8. So I can say minus 8x then plus n. What is n? N is 6 plus 6 is equal to 0. I think this will reduce to, if I divide through by 2, it will be x squared minus 4x plus 3 is equal to 0. Now, you can just try and factorize this to see that it will actually give us this as a root of the equation. For example, we have minus 4x, that will be x squared minus 3x minus x plus 3 is equal to 0, such that I will have x common to both, x minus 3, then minus 1 common to both, minus 1, note that x minus 3, so that minus 1 times minus 3 will be plus 3. This is 0. So here again, x minus 3 is common, and then we have x minus 1 remaining is 0, such that x is 3 or x is 1. I just took this as a check. Okay, this is just a check. You don't need this in the exam. Once you are able to get 6 and minus 9, that is fine. But I just want to show you students to do this, then you can arrive at the same answer. Interestingly, like I said initially at the starting point, you can reverse engineer to say, okay, x is 3 or x is 1. Then you want to open bracket like this, and then after opening that bracket, you want to multiply out, you will get this, and eventually you arrive at this equation, which you can now equate to this, that m plus 1 is minus 8, and then n is 6. You arrive at the same answer, and your full mark will be awarded on your way to excellence. All right. Okay, we have this question on equations, and we're told that in an athletic competition, 812 tickets were sold for $1,912. If the student paid $2 per ticket and non-student paid $3, how many more students than non-students were present? Okay, I think I like the idea of this type of question. So let's say x should represent the student, and then y should represent the non-student. Okay, so if that is the case, we can go ahead to say we want to interpret this now. The total number of tickets that were sold was 812. That means that we can say x, the ticket bought by student, plus the total tickets bought by non-student, everything is going to be 812, and we can append this as our equation 1. Okay, and then now these were sold for $1,912. No problem. There's a breakdown. Student pay $2 per ticket, so x is for student, so 2x, the amount paid for ticket by student, plus non-student paid $3 plus 3y, that's the amount paid by non-students. The total of that is giving us 1,912, and we can take this as equation 2. Okay, so we want to get the difference in numbers between those who are students and those who are not students. What I would like to do in this case is that equation 1, I'm going to multiply it by 2. Okay, let me just do that. Then I will have 2 multiplying each of these terms will give me 2x plus 2y is equal to, this will be 1624. Okay, and then I can tag it as equation 3. Having done that, now what I want to do is to say, looking at this equation 2 and equation 3, I can subtract. I can say equation 2 minus equation 3. We can see 2x minus 2x, that will be 0. So that I can say is actually out of discussion. Then I have 3y minus 2y, and that will be y. 3y minus 2y is equal to 1912 minus 1624. 1912 minus 1624. So here I'm going to have y is equal to, what's this? Let me use my calculator. 1912 minus 1624. Okay, y is 288. That is the non-student. But then if I got that to be non-student, I can get from equation 1, from 1, I can see that x is going to be 812 minus y, and y I got to be 288. So x will be 812 minus 288. Then x is going to give me what? 812 minus 288. This is 524. 524. Okay, that's good and very fine. But now we're being told how many more students than non-students were present. So the more students, the number of more students will have to be the difference between these two, and that will be 524 minus 288. Okay, so we have 524 minus 288, and that's going to give me 236. So that is equals to 236. So what we are looking for is nothing but 236 students were around in that competition, more than those who are non-students. All right. Here we are told that two numbers are such that twice the first added to the second is 21. If twice the second added to the first is 27, we have to find the number. So let x and y be the numbers. If x and y are the numbers, we can use the interpretation of this statement to solve this question. In the first case, twice the first, so we have 2x added to the second plus y is equal to 21, all right? And then twice the second added to the first is 27, so the first x plus twice the second 2y is equal to 27. Again, we have this as two equations, equation 1 and 2. And to solve this, I think I would like to say, let me do equation 1 multiplied by 2 so that I'll be able to eliminate y. So that will give me 2x times 2 is 4x plus y times 2 is 2y is equal to 21 times 2, that will be 42. So I can call this equation 3. And then looking at this now, I can just see that for equation 2 and 3, 2y is common to both of them. So I can say equation 2 minus equation 3. And in that case, for the first terms, x and x, I have x minus 4x. Now, 2y minus 2y will be 0. We don't need to write that. This is going to be equal to 27 minus 42. So I'm having minus 3x is equal to 27 minus 42. That will be minus 15. And if I'm dividing by minus 3 on both sides, this first case, minus 3 will cut. And then minus 3 in minus 15 will give me 5. So the value of x is 5. That is the first number. Okay. The second number, from here we can say from equation 1, y will be 21 minus 2x. Therefore, y will be 21 minus 2 multiplied by 5. So that will be 21 minus 10, which is 11. So from what we are asked, we can readily say that the first number as it was depicted is 5. And then the second number as asked for the question is nothing but 11. And we can just verify. Twice of the first number, that will be 2 times 5, that is 10. Plus the second, 10 plus 11, of course, that's 21. Twice the second, 2 times 11 is 22. Added to the first, 22 plus 5 is 27. That is 27. So we're on the right track, and this is our solution as expected of us. In this question on angle of depression, we are told that from the top of a tower 80 meters high, the angles of depression of the top and bottom of a building are 28 degrees and 36 degrees respectively. Students, that means that the angle of depression of the top is 28 and that of the bottom of that building is 36. That's how we're saying respectively, okay? Now, if the base of the building is on the same horizontal level as the foot of the tower, we have to calculate correct to 4 significant figures the height of the building. So a picture is always worth 1,000 words. This is going to be a similitude of what we are going to be having in this particular diagram. If you are to look at it, we have the tower and we have the building. Because we are told that the angle of depression from the top of the tower, so that means the tower will have to be higher for the building sighting to be a depression of the view. So initially, let's say this particular person that is on the tower is trying to walk on the tower but is looking down on the building. Maybe then he is looking initially like this. Then the angle of depression to the top of the building, this. And then the angle of depression to the bottom of the building, this. That is just what is highlighted for us. Furthermore, we are told that there is a particular height for the tower. Okay. So that height we are given as 80 meters. And then our mandate is that first we have the angle of depression of the top of the building. This is the top. So from his horizontal view, his initial horizontal view to that, we are going to have something like this, that this is 28 degrees. So let me depict that as such. Okay. And then I will use another hint for this. The angle of depression of the bottom of the building, now that will be from that initial horizontal viewing to the inclination of the bottom of the building. That was given as 36 degrees. Okay, so that was shown in red. For the top is shown in blue. So our mandate is to find the height of the building. So for us to identify the height of the building, we'll be looking at something like this. Let's say we have this there, okay? Then we'll be looking at from here to here that this is the height of the building that we are asked to find, okay? And we are asked to get it correct to 4 significant figures. So good. Now that we have the diagram, let me just tone our image so that we will not be unnecessarily confused, okay? So if you have that as shown now, we can see that we have this diagram that we can try and complete. Let's say I just want to finish up by joining this line to that diagram we're coming from. Okay, oh, beautiful, beautiful. So I may also want to label. Let me say I want to call this A, B, C, D, and maybe I can call this E. All right, we are looking for H. Already the height of the tower is corresponding to AE. Because it is parallel to BD, they are going to be the same. So AE and BD, they are the same. But for us to get this height, we will notice that that height is going to be the height of the tower itself, which is 80 meters, minus this side BC. Okay, so the height that we are looking for, let me say height of the building that we are looking for, the height H, is going to be the length of BD, which is also AE, that is 80 meters, minus this BC. Minus BC, but okay, let me just call BC, let me call it, since it is facing A, let me call this A. So I will say 80 minus BC, or 80 minus A, okay? Then how do you go about finding A? Now, for this particular A, it is included in this triangle ABC. We don't know any of the sides, but we know this included angle 28 degrees. That's good. Looking for A, not knowing any of the sides. These sides AB, this side AB, we can get from the bigger triangle ABD, because for ABD, we know that BD is 80 meters, which is going to be the opposite to this angle 36 degrees, and then we can use AB at its adjacent. So we are looking for the adjacent, we know the opposite, definitely we know the angle, and then we can use those parameters to get that adjacent. So this adjacent, let me call it X. That means that I can say from the triangle ABD, first the bigger triangle ABD, I'm having the, okay, I want to make use of SohCahToa, so that I can have that as a reference. Now, I'm having the opposite, which is BD. I'm looking for the adjacent, which is going to be relevant to me. It is tangent, because tangent is opposite over adjacent. So I can say the tangent of, now I'm talking about the bigger triangle, it will be angle 36, then 36 is equal to the opposite, that is BD, and that BD we know is also equal to AE over what is the adjacent? The adjacent is AB for that triangle. Now that BD, of course, I have tagged as AT. AB I have tagged as X. So here, if I just cross multiply, I can say that means that inherently X is going to be 80 over tan 36. Okay, so what's that going to give me? I will use my calculator to try and solve this. So I'm having 80 divided by tan 36. Okay, so this is 110.11, let me say 111. This is 110.111 meters, but that's not where I'm going. Now, since I have the value of adjacent AB, which is X, I can now find A. I can say from the triangle, the smaller triangle now, ABC. Again, what we have is the included angle, which is 28 degrees, that smaller one. Then I want to relate the opposite of it, which is BC, to the adjacent. Tangent is still going to be what will be relevant for us. So I can say tan 28 now is going to be opposite, which is BC, over the adjacent, which is AB. And of course, that opposite is nothing but A. The adjacent is X. So my A, which is what I'm looking for, is going to be, now if I cross multiply in this case, going to be X tan 28, but X I just got to be 110.111, so I have 110.111 tan 28. Okay, so calculator will help me to solve. Oh, just the initial answer multiplied by tan 28. What's that going to give us? 58.5468, 58.5468 meters. But then that is A. The height of the building we are looking for, already we have said it initially that that height is nothing but 80 minus A. And now look at A. A is 58.5468. So if you want to do that, you can say 80 minus the answer we just got, 21.4532. That's 21.4532. But look at the question. We have to get it correct to 4 significant figures. And that means that, students, you need to understand that even if you are having decimal place, your significant figure, the digit after the decimal place, they will still count. So that height will have to be 21.45 meters, because 3 is less than 5. We will round it down to 0 and did not affect the digit before it. So 21.45 meters is going to be the height of this particular building as featured in this question. All right. Yeah, in this question of mensuration, we are told that one of the diagonals and perimeter of a rhombus are 32 centimeters and 80 centimeters respectively. That means the diagonal is 32 and the perimeter is 80. That's why we're having the word respectively. Our mandate here is to find the area. Now, if you are to take a look at the picture of a rhombus, ideally, we know that the area of a rhombus is given as 1 over 2 multiplied by the product of the diagonal, so D1 and D2. And in this diagram, if you want to identify those D1 and D2, you can say you want to join from this vertex to the one opposite it. And also, okay, let me use another ink for that. And also something like this. Okay, so this is D1 and this is D2. And that is how we actually go about getting the area of the rhombus. But interestingly, we are told that one diagonal is 32. So if I take this as the red as 32, that means here, let me say this is 16 and this is 16, so that the addition of the 2 will be 32. Good and fine. Now we are told that the perimeter will mean that the sum of all the sides. For a rhombus, the sides are equal. So if this is A, then definitely this is also A, this is A, and this is also A. So we have it that we can say 4A is equal to the perimeter of this particular rhombus, which is equal to 80. And in that case, A is going to be 80 over 4, and that is 20 centimeters. So we can say we are looking at something like this. Say this side is 20 centimeters. Now, looking at this already, the diagonals are observed to be dividing the rhombus into 4 triangles in which at the center we have 4 right angles. Okay, so if that is the case, we can see that for this particular one, let me just try and see if I can color it for you to see clearly. Here and here, we can see that that is a right angle triangle in which we have the hypotenuse and we also have one of the sides. So if I call this other side, let me call this other side, let me call it H. Okay, and of course this will also be H. Okay, this is H, because like we did for the red diagonal, we are dividing it into 2 equal parts. This will also be H. So from here we can say that by Pythagoras theorem, recall this is the perimeter that we actually use to evaluate the side A. Now we can say that by Pythagoras theorem, we are saying that here for this triangle, 20 square is equal to 8 square plus 16 square, and that means that 8 square is going to be 20 square minus 16 square. We can use the difference of 2 squares in this case to say this is nothing but 20 plus 16 multiplied by 20 minus 16. Okay, so 8 square is, what is 20 plus 16? That's 36. 20 minus 16, that is 4. 36 and 4 is just as say you are saying 12 and 3 times 4, 12. So this is 144, such that H is the square root of 144. Okay, so from here we have it that our H is equal to square root of 144 is 12 centimeter. Originally we have one of the diameter, so if we call that D1, that we are given as 32 centimeters. We have deduced from this diagram that D2 is going to be H plus H, so that is 2H, and that is going to be 12 times 2, that is 24 centimeters. Okay, so that means we can find our area from where we are coming from, that the area is going to be 1 over 2 multiplied by D1. What is D1? That is 32, and again multiplied by D2, that is 24. So we can use our calculator to solve this now, to say we have 0.5, which is 1 over 2 multiplied by 32 multiplied by 24. What is going to give us? That's 384. So this is 384 centimeters square as the area of this particular rhombus. Now, good as that is, interestingly, there is another route we could have taken. We could have said that the area of this particular rhombus, since the diagonals are dividing them into equal parts, that means we can say it is 4 multiplied by the area of one of the right angle triangles that we have, because this right angle triangle is equal to this one and this one and this one. So we can say it is 4 multiplied by half multiplied by the base and height, which in this bracket, that is the area of this particular triangle. So if we want to do that, we could have said it is 4 multiplied by 1 over 2 multiplied by, what is the base of this triangle? It is 16. What is the height? It is H, that we got as 12. Okay, and to evaluate that from the calculator, we'll see that this is 4 times 0.5 times 16 times 12. Okay, and what's that going to give us? You can see that is also 384 centimeters squared, just as we have gotten initially. So whichever method you choose to use, just be consistent and you see that your answer is out and your work is done and dusted. All right. In this question of mensuration, we are told that the area of an equilateral triangle is 2 root 3 meters squared. We are to calculate the length of a side of the triangle. Okay, so what are the properties of an equilateral triangle that we know that can be useful for us to solve this question? First and foremost, the side of the equilateral triangle, they are equal. So this side and this third one, they are equal. Okay, and then the angle included in the equilateral triangle, each of the angle is 60. So that 60 plus 60 plus 60, that is 180, summing up to the sum of angles of a triangle. So I can say here, this is 60, here this is another 60, and here I have another 60. Okay, but now we are given this question that the area of this particular equilateral triangle is 2 root 3 meters squared, and we are to find the length of a side of the triangle. So let's call this side, let's call it B. Okay, so how can we go about trying to solve this question? One thing I'm noticing is that if I choose to bisect this triangle, to say I'm dividing it into 2 equal parts. Now for this particular base, since I'm dividing this length into 2 equal parts, then here I'm going to have b over 2. This is also going to be another b over 2. This angle that are bisected, initially it was 60, now this is going to be 30 degrees, and this is also 30 degrees, whereas this is 60 degrees. So I can just, let me note it like this, that this is 60, however this here, that is 30. Okay, now if I tag this particular vertical line, if I tag it as h, okay, I know that doing all this will also warrant that the area of this side of the triangle, this right angle triangle, will be half of this. Okay, so that area of this particular half side, this right angle triangle, okay, let me just label A, B, C, D. Initially this is area of triangle, let me call this area of triangle ABC, is this as given originally. Now area of triangle ABD, half of that is going to be 1 over 2 into 2 root 3, which is equal to root 3 meters square. But I know by reason of this rectangle triangle that the area of that triangle ABD is actually half multiplied by the base multiplied by the height. But let's notice something here. What is the base of this triangle? It is b over 2. So I can put it appropriately that half multiplied by b over 2 multiplied by the h, which is bh over 4. Now I did that because I can actually find h by reason of SohCahToa. So if I want to say I'm using SohCahToa and I want to take one of the, okay, let me say I want to make use of 60. For 60, I can say that h is what? H is the opposite to 60. B over 2 is the adjacent to 60. So I can say tan 60 is equal to the opposite, h over the adjacent, b over 2. Okay, therefore h that I'm looking for is b over 2 tan 60. So that means I can use that value of h in this particular case. So say instead of saying h, I have it as b over 2 tan 60. Okay, so that area, this particular area that I have here, I can express it as this now. Okay, I can say in trying to relate that the area of that triangle, half of that triangle, which is triangle ADB, area of triangle ABD, is going to give me something like this. I got it initially as root 3 is equal to bh over 4. Let me say I have b over 4 that I want to write straight, b over 4. Now what is h? H I'm saying as b over 2 tan 60. So what is tan 60? Tan 60, we can say we want to use our calculator. So what is tan 60? Okay, tan 60 is even root 3. Good and fine. Okay, so I have it as b over 4, which is this b over 4. H is now b over 2 tan 60. That tan 60 I just got to be root 3. Okay, so looking at this now, I can say that root 3 is going to cut root 3. So with that, I can say here 1 is only going to remain here. I can say 1 is equal to b times b is b squared. 4 times 2 is 8. Now if I just cross multiply here, I will have it that b squared is equal to 8. Therefore b itself is root 8, and root 8 is actually 2 root 2, because it is 8 is 4 times 2. Square root of 4 is 2. That's here. Then that square root of 2 remaining will still be here. And this is going to be the length of the side of this particular triangle, this particular equilateral triangle, whose area is 2 root 3 meters squared. What we did is that we are looking at the area of the full equilateral triangle. If we divide it into 2, we are going to also divide the area into 2. But then we know that dividing it into 2 will render we're having a right angle triangle whose area is half base times height. Now the base here is corresponding to b over 2, half of the side of the original equilateral triangle. So SohCahToa with tan 60 helps us to find the height. We don't need to express the value of the height out. We just use it in the original equation for the area of the right angle triangle to get the side of this equilateral triangle to be 2 root 2 meters. All right. This question is featuring a combination of mensuration and number base. So let's just take our time to look at it together. We are told that Mr. Kubi has a backyard garden in the form of a rectangle. Okay, now the breadth of the garden is 212 base 3 meters and the length is twice the breadth. Our mandate is to calculate the area of the garden and leave the answer in base 5. Okay, so let's have a pictorial view of what we are being told here. We are told that first and foremost the breadth of the garden is 212 base 3, so we can say this is 212 to base 3, and then the length is twice the breadth. So here we can say this is nothing but 2 multiplied by 212 base 3. Okay, so we have to calculate the area of the garden and leave the answer in base 5. Since it is in the form of a rectangle, the area will be the length multiplied by the breadth. Okay, so you can say you want to do it directly. Okay, that here we can just say area of this rectangle is going to be 212 to base 3, okay, multiplied by 2 times 212 to base 3. Okay, if you are very proficient in number base, you can say you want to multiply this out straight, but for me, as a rule of thumb, since we are going to be having mixed students, I would first like to convert 212 in base 3 to base 10, multiply in base 10, and then convert to base 5 to solve as we are requested in this particular case. Okay, so I can say in 212 of base 3, if we want to take this and convert to base 10, we are going to have it that each of these digits, in the first case we have 2, we multiply by 3, I will come back to the power, plus 1 multiplied by 3, then plus the last digit 2 multiplied by 3. Now for the power, I need to start from this right hand side and take the power as this is 0, this is 1, and this is 2. So inherently what I'm going to have is, in this case, 3 raised to power 2 is 9, 9 times 2, that is 18, plus 3 raised to power 1 is 1, 1 times 3, that is 3, plus any number raised to power 0 is 1, 1 times 2, that is 2. So this is 18 plus 3 plus 2, and that is 23 in base 10. Okay, so what we are having as the area, therefore the area of this rectangle is going to be 23, which is in base 10, multiplied by 2 times 23, because this is going to be the breadth, the length is 2 times the breadth, so this is what we have. So we can just say this is nothing but, let's use our calculator now, this is just 23 times 2 times 23 is 46. So what's that going to give us? 1058. So this is 23 times 46, which is 1058 meter square. Okay, but now we are not asked to get the area in base 10. This is in base 10. We are asked to leave the answer in base 5. For us to do that, we just need to divide this particular area by 5, and we take the remainder. That's going to be what will give us the answer in base 5. So we have 1058. We'll be dividing with 5. Okay, and then we can just do our long division to say we should have something like this, and then we are dividing straight like this. So we are having 5 in 10, that will be 2, 5 in 5 is 1, 5 in 8 is 1, remainder 3, so we have plus 3, because 5 times 1 is 5, plus 3, that will be 8. Again, we are using 5 to divide this. Okay, and if you are dividing like that, we are going to say what we are having is nothing but 5 in 21, that is 4, 5 times 4 is 20, remaining 1. 5 in 11, that is 2, there will also be a remainder of 1. Okay, again 5 in 42, that is 8, 5 times 8 is 40, remaining 2, so we have 2 remaining. 5 in 8, that is 1, 5 times 1 is 5, we are going to have 3 as a remainder. So finally we can say 5 in 1, what is that going to give us? Is going to be 0, okay, as 1 is way less than 5, and what is going to remain? We are going to have that 1 remaining. Okay, so the answer that we are looking for in this particular case will be we taking this and taking it up to say our area that we are looking for is nothing but 13213. Let me move this a bit so that we have space to put my work. Okay, so inherently I'm saying that my area is nothing but 1058 meters square in base 10, but in base 5 it will be 13213. 13 to base 5 meter square. Let's write just the way they wrote for us, and this will be the solution to this question, done and dusted. All right. For this question on mensuration, we are told that 4 of the interior angles of a heptagon. So first, you need to know what is a heptagon, okay? They are 106 degrees, 110, 127, 120 degrees, okay? Now, the remaining angles are in the ratio 2, ratio 3.5, ratio 5. We have to calculate the smallest angle of the heptagon. Even if you don't know what a heptagon is, you can count these angles. So say this is 1, 2, 3, 4, 5, 6, 7. So an heptagon is a polygon that has 7 sides. In short, as a refresher course, quadragon is 4, pentagon is 5, hexagon is 6, heptagon is 7, octagon is 8, nonagon is 9, and decagon is 10. Okay, so in this particular case, we are looking at a polygon with 7 sides. So 7 sides is of interest to us in this particular case, and the sum of interior angles of a polygon with n number of sides is given as n minus 2 multiplied by 180 degrees, and here in this case we have n to be 7. Okay, that is good and fine. So with all of this understanding, we can say we want to have all of the angles. To say we have 106, we have 110, we have 127, we have 120. Now with what I just explained, we are going to have 2x, we are going to have 3.5x, and we are going to have 5x. Now, since you know that the sum of the interior angles of a polygon is given as n minus 2 divided by 180, and in this case n is 7 for heptagon, then the sum of angles, we can say 106 plus 110 plus 127 plus 120 plus 2x plus 3.5x plus 5x is going to be 7 minus 2 multiplied by 180 degrees. So let's bring in our calculator to try and solve this. We have 106 plus 110 plus 127 plus 120. What's that going to give us? 463. So we have 463 plus 2 and 3.5 is 5.5 plus 5. We have 10.5x is going to give us 7 minus 2 is 5. 5 times 180 will be 900. Okay, therefore 10.5x is 900 minus 463. Okay, and if you use our calculator for that again, 900 minus 463, this 437 is 437, so that x itself is 437 over 10.5. Okay, so our final answer that we just got divided by 10.5, this is 41.61. so it's repetitive, that's why we have this bar. I can just say 41.62. so this is 41.62 degrees. Now look at this. Nobody asks us to find x, we are asked to find the smallest angle of the heptagon, and then we are having the base divisor as 41.62. and look at all of these values. Look at all of these values that we have. Which one is going to be the smallest? Of course 106. All the ones that we are given, they are quite large. So we have between these three that we're having a base divisor to consider, and of course 2x is actually the least of it all. So we can say for this particular case, the smallest angle, the smallest interior angle of this particular heptagon is going to be 2x, which is 2 multiplied by 41.62 degrees. And if you are to use a calculator for that, you can say what we got multiplied by 2 and then straight, it will be 23.24, 83, not 23, 83.24 degrees as the smallest angle for this particular heptagon. All right. In this question, we are told that the sum of the first 10 terms of an arithmetic progression, that is an AP, is 120, and of course that's telling us that this is a question in sequence and series. Now, if the fifth term is 6 less than the 8th term, we are to find the common difference and the first term. So let's take the information we have here piecewise. In the first case, we are saying that the sum of the first 10 terms is 120. But from understanding of arithmetic progression, what is the formula for the sum of the first n terms of an AP? It is giving us n over 2 multiplied by 2a plus n minus 1d, okay, where n is the number of terms. Then we have a to be the first term, and then d that we are featuring is the common difference. That's the common difference for that particular arithmetic progression. So it is this formula that is inherently equal to 120 for the first 10 terms. So that means that we can say when n is 10, okay, let me just write that. For n equal to 10, then what we have is that S10 is now being given as 120 is equal to n over 2 will be 10 over 2. So we have 10 over 2 into 2 multiplied by the first term plus n is 10. So we have 10 minus 1 multiplied by the common difference. Okay, so if we simplify this, we can just have these two can cut 10, and then 5 can go in 120. That will be 24. So what we have inherently is that, okay, let me just open this, 2a plus 9d. So we have 2a plus 9d is going to give us 24. So we can note this as one equation that we can find useful. I'm calling it equation 1. Now the second statement, we are being told that fifth term is 6 less than the 8th term, means that we have t5 is equal to t8 minus 6, okay? Or if we rearrange this, we say t5 plus 6 is equal to t8. But normally between t5 and t8, how many common difference are we going to have? From t5 to t6, that is 1d. t6 to t7, that is another d. t7 to t8, that is another d. So what we are having is that we can say t5 plus 3d is equal to t8 from the explanation that we have. And that means that, look at this, d6 is actually 3d. So what we can say is that that means that 3d is equal to 6, such that in this particular case, d will be 6 over 3, and that is nothing but 2. And that is giving us the first answer that we're looking for, that the common difference is actually 2. Okay, now for us to get the first term, look at this particular expression, the equation we got initially, that 2a plus 9d is equal to 24. So we have 2a plus 9. What's the value for d? We just got it to be 2 is equal to what? That is 24. So from here, we can now say that looking at this, it means that 2a is equal to 24 minus 9 times 2 is 18. So 2a is equal to 24 minus 18, that is 6. That means that a will be 6 over 2, and that will be nothing but 3. In this question on circle theorems, we are told that in the diagram, PQRS is a circle, then angle QRP, this angle here is 41, angle PTQ, this angle here is 35, then PT, this is PT, is a tangent to that particular circle, and then line QR is parallel to line PS. That's why we're having these double arrows on each one of them. Our mandate is to find angle first PAQ and then PQT. So let's identify PAQ. We have PAQ, so it is this angle here. If I'm to just depict it like this, so this angle is what to find, okay? And then looking at this particular diagram, how best can we go about trying to solve for this angle? There are so many ways that you can choose to go about the student. You can try your hand on them. Let me just, by reason of just looking at it, let me just postulate one. If I'm to say I'm drawing another parallel line like this, now this 41, we also render this as 41, okay? This particular angle here is also going to be 41 because it is the angle in the same second like this. We have QRP, we have QSP. So QRP and QSP are in the same second. So this is also 41. Then this 41 is also this particular 41 because again, it is alternate to that. And this angle we are looking for is just, you can see, this angle here and this angle here, they are vertically opposite. So I can say this is equal to 41 plus 41, and that is 82. So that is one means that you can go about, and there are even so many other means, but this is the format that I want to follow. This angle QAP, if I call it theta, okay, I'm looking for theta. This is what I would like to do first and foremost. I will say this angle QRP, okay, angle QRP is also going to be angle QSP, and that value is nothing but 41 degrees. And why am I saying that? Because they are angles in the same segment of a circle. So angles in the same segment of a circle, they are equal. So that is also 41. So I can just say QSP, this here is also 41 degrees, okay? And then apart from that, if I look at this QRP also and RPS, this angle here, they are also going to be equal. It's 41 because they are alternate angles. So I can say angle QRP is also equal to angle RPS, this one here, and that is also 41 degrees. Why am I saying that? It's because they are alternate angles. So I'm doing another method of solving it, but eventually we'll still arrive as 82 as the same answer. Now, looking at this triangle from triangle APS, we can see that this theta we are looking for is exterior to these two angles. So we can say our QAP that we are looking for is going to be angle QSP plus angle RPS. Why? Because exterior angle of a triangle is the sum of the two opposite interior angles. Okay, in short, even for that, you can say first we want to look at this, that the addition of the 3 is then theta plus that angle is 180 because the angle on a straight line. So there are just so many ways you can choose to go about it, but I think I love this to say then in that case angle QAP is going to be, what is QSP? We have gotten QSP as 41 before, that is 41 degrees, plus what is RPS? We have gotten RPS also to be 41 degrees initially, such that the addition of the two is going to give us nothing but 82 degrees, just like we postulated originally. So you can also take this as an exercise. Look at so many other means in which you can try to solve this, but with this we've been able to solve the first question. You can now move to say we want to look for the solution to the second question. All right, now in the second part we have to find angle PQT. Let's identify that angle PQT. So we'll start from P. Okay, so we have P here, and we are going to Q, and then we are going to T. Now, sometimes you have questions like this that you need to actually include the angle you are looking for. So in this case, PQT is what we are looking for, and it is as shown here, and I will just try and color that so that we will get to see it. So it is that angle that is shown in red. I can call that alpha. That is the angle that we are also looking for. So once we've identified like this, you can say we want to solve for this angle PQT that we identify as alpha. Okay, now looking at this particular diagram, originally in the question we are told that PT, this line at the base, is a tangent to the circle, and there is an angle that that tangent is making with this particular chord of the circle. So if I want to depict that out, I can say I'm looking at this angle here, and that angle and this particular one here, actually they are going to be the same, because that is what the alternate segment theorem is telling us. So I can say this is also nothing but 41 degrees. And why am I saying that? Let me just write it out, that I'm seeing that angle QRP, that is also equal to angle QPT, and the value is nothing but 41 degrees because it's the alternate segment theorem. That's one of the theorems in circle that is going to be useful for us, that the angle between the chord and the tangent of a circle is equal to the angle in the alternate segment. So that is what we are putting into play like this. And once we have gotten that to be 41, we can see that this triangle PQT is a triangle that we know two of its angles. We know 35, we know 41. We are looking for alpha. So we can say already angle PQT, which we are looking for, plus angle QPT, which got to be 41 here, plus angle PTQ that we are given. The sum of everything is 180 degrees. Why? Because they are the sum of angles of a triangle. Sum of angles of a triangle. And the sum of angles of a triangle is nothing but 180 degrees. Therefore, the PQT that we are looking for, which we call alpha here, we can say that PQT plus QPT, which is just going to be 41, plus PTQ, this one here, which we are given as 35, the sum of the three is 180 degrees, such that PQT that we are looking for is nothing but 180 minus the sum of these two. This will be 76 minus 76. So we have this as 180 minus 76, 180 minus 76. What's that going to give us? That is 104. So this is nothing but 104 degrees. And as beautiful as it gets, that is just the solution. You can also look at the diagram and look at the theorems that you can find useful to try and solve this particular question. There is not just one singular way to solve questions like this. No. Just like we saw in the first question, you can look at it. In short, I'm challenging you. Look at it and postulate other means by which you can get the solution, and just ensure that we arrive at the same answer and your work will be done and dusted. In this question of statistics, we are told that the table shows the height of players of a basketball team. This table here, we have to calculate correct to one decimal place in centimeters the mean height of the player. So this is a very good question asking us about mean. And what is the formula for mean? Mean, as typified in this case, will be summation of the product of frequency and data entry over summation of frequency. So which one is the frequency, which one is the data entry here? This height, which we are asked to find the mean of, will be the data entry, and the number of players will have to be the frequency. Okay, so if you are to do that, we can just say for this case the mean is going to be the product of each of these entry in the columns. So we sum them together. So we have 4 multiplied by 160 plus 6 multiplied by 161 plus 3 multiplied by 162 plus 7 multiplied by 163 plus 8 multiplied by 164 then plus 9 multiplied by 165. So that is summation fx. We are using that and we are saying we'll be dividing everything there with summation f. That's the addition of all of the frequencies. So we have 4 plus 6 plus 3 plus 7 plus 8 and plus 9. So we just need to be careful to ensure that we put in the right values into the calculator. The first one is 160 and 4, 161 and 6. Okay, so I'm having 160 times 4 plus 161, let me just be putting it in bracket so that I don't make mistake, times 6, then plus 162 times 3 plus 163 times 7 plus 164 times 8 and plus 165 times 9. Okay, so what's that going to give us? That's 6030. So this mean is nothing but 6030 divided by, let's sum the frequencies. We have 4, 6, 3, 7, 8, 9. We have 4 plus 6 plus 3 plus 7 plus 8 and plus 9. 4, 6, 3, 7, 8, 9. So this is 37. So we have it as over 37. So this is going to be our mean height. So we have 60, 30 divided by 37. Okay, so this is 162.972. This bar means is being repeated. So 162.972972. So this is 162.972 0.972972 and repeated on and on like that. But look at this, we have to find it correct to one decimal place. Okay, so if you want to take it to one decimal place, that means one decimal place will mean that this is just the digit that we'll be considering, but we need to look at digit after it, and it is 7 greater than 5. We round it up to 1 and add to the initial digit. If we add 1 to this, of course it turns it to 10. So that means it is 163.0 that is going to be the mean height of these players in question. So we can say our mean height is going to be 163.0 centimeters as the solution to this question here. In this question on probability, we are told that a bag contains 4 blue, 5 green, and 6 red identical balls. Now a ball is selected at random from the bag and then replaced before a second ball is then selected. So we need to notice that the first ball that was taken is always replaced before the second one is selected. That means this is actually a set of independent events because there is replacement of the balls. So our mandate is to find the probability that the balls selected are, in the first case, both are green. In the second case, 1 blue and 1 red. In the third case, all of the same color. So if you want to have a look at what we are talking about here, we will have something like this. And then looking at what we're told that there are some 4 blue balls, and after that we are looking at 5 green balls, and then in addition to that we are looking at 6 red identical balls. Okay, so that's what we have, meaning that from here we can know that the total number of balls that we have is just the addition of all of this, which is 4 plus 5 plus 6, and that will be 9 plus 6, that is 15 balls. So in this case 15 is the total number of balls that we are looking at, and that is going to be the total number of probability that we could have gotten no matter the situation. But now let's take it piecewise. In the first case, we're talking about 2 balls and they are saying we should find the probability that both are green. So we are looking at probability of the first one is green and the second one is also green. So it's probability of green and green. And in this particular case, what is the probability of picking a green ball? It will be the possibility of a green, which is 5, over the total probability, which is 15. But since we are talking about and, that means we need to multiply. Okay, again in the second case the ball would have been replaced, so the number of greens are still 5 and the total are still 15. So this is what we need to look like. We can of course see that we can have this as 1 over 3 multiplied by 1 over 3, such that that probability is 1 over 9 in the first case. Okay, now we need to be careful as we move on, because in the second case we are talking about probability of 1 blue and 1 red. Hey, so now is either we have that probability is, in the first case we have blue and then in the second picking we have red, or the probability that in the first case we have red and then in the second case we have blue. So these are the 2 case scenarios in which we can have 1 blue and 1 red. So this is what we are going to have for 1 blue and 1 red. It's either we pick blue first and then red after, or we pick red first and then blue after. So if we want to look at that, for that too, that means we are looking at, let's use the guide of what we have there. That means that for blue is 4 over 15. That's probability of picking a blue ball. But now we are saying and red, it would have been replaced, so it will still be 6 over 15. And then when we are having or means addition in probabilities, we have plus. Now red first will be 6 over 15, then and blue, that will be 4 over 15. Okay, or we can even simplify that this is nothing but 2 multiplied by 6 over 15, because it's the same thing, okay, times 4 over 15. So we can use our calculator to try and evaluate this, to say we have 2 into brackets, first we have 6 over 15, then we are multiplying that with another fraction which is 4 over 15. Okay, so we can close that, check that we are on track, and that is what, 16 over 75. So this is 16 over 75 as the probability of picking 1 blue and 1 red. Okay, and then in the third case again we need to be careful here. we are to find the probability that the two balls selected are of the same color. Okay, in this case, what we're going to have for them to be of the same color will mean that in the first case, we are picking either, okay, let's start with the order in which we are giving. In the first case, we are picking blue and blue. In the second case, we are picking green and green. In the third case, we are picking red and red. So in the first case, that means we're having probability of blue and blue, plus in the second case, we're having probability of green and green, okay, plus in the third case, we're having probability of red and red. Okay, so this is what we actually need to work with to say we can get this. And for us to solve this, it's going to be that blue and blue will be 4 over 15 times 4 over 15, okay. Then green, we have 5 over 15 times 5 over 15. Then red plus 6 over 15 multiplied by 6 over 15. Okay, so this is what we can make use of now. Okay, let me just reduce my work area a bit. So in this particular case, I will just want to leave the base as the same and just multiply the numerator. 4 times 4, that is 16. 15 multiplied by 15, what is that going to give us? 15 times 15 is 225. So this is 225 plus here 5 times 5, that's 25 over 225. Again, 6 times 6, that is 36 over 225. So what I'm going to have eventually is that I'm having the addition of these three, 16 plus 25 plus 36, that's what 77. So I'm having this as 77 over 225. You can leave as this, or you can say you want to say this answer, which is 77 divided by 225. What's that going to give us in decimal? 0.342. But since I've been putting everything in fraction, let me just leave this as fraction also. So it's the understanding of the fact that these are independent events that really helped us to solve this, and we got our answer as shown here. Okay. In this question on trigonometry, we are told that given that sine 5x minus 38 degrees is cos 2x plus 16 degrees and x is having its range of values between 0 and 90, we are to find the value of x. Now, for us to really understand this, I've come up with this triangle that I will help us to understand, because we are being told that actually x is between 0 and 90. Inherently, this is calling it nothing but a right angle triangle. And for a right angle triangle, if we have one of its angles to be 90 already, yeah, this is 90. I want to look at the other angles. In this case, if I call this theta, by reason of the understanding that the sum of angles in a triangle is 180, 90 is out of it already. Now we are taking theta out of the remaining 90. So this place definitely will have to be 90 minus theta. And you want to apply trigonometric identity, SohCahToa. Let's just take it piecewise. That what is, let's just take sine and cos of one single case, and I believe we should be able to get the other one. So if I say sine theta, in this case, what is sine theta? This is theta. Sine theta will be opposite over hypotenuse. And what is the opposite of theta here? It is this c. So that is c over, what's the hypotenuse in this case? It is b. Okay. If you are observant, this c over b is also going to be the cosine of 90 minus theta, because what is cosine? Cosine is adjacent over hypotenuse. So for 90 minus theta, what is the adjacent? It is c. What is the hypotenuse? It is still that b. So we can say this is also going to be cos 90 minus theta. As a rule of thumb, we just have it that sine theta is always equal to cos 90 minus theta. Okay, so I took time to actually explain that, because that is what will help us to solve this question that we have here and demystify it holistically as expected of us. So in that case, I can say, since we have that sine of this angle is equal to cosine of this angle, that means that inherently I can say let 5x minus 38, let this be my theta. Okay, then in that case 2x plus 16 will be what? 90 minus theta. I hope this is well Understood? Okay, it is this that will help us to really solve this question. And then if I'm to just tag it as this is equation 1 and this is equation 2, I can simplify equation 1 to say I have it as 5x minus theta is equal to 38. I just collect unknown terms to the left hand side, and then in this second case I have 2x, then this minus theta when it comes to this side it becomes plus theta is equal to 90. When 16 I subtract from both sides, it will knock out from this left hand side. On the right hand side, 90 minus 16, that will be 74. So I have these two equations that I can say I want to solve. Since I have negative theta, positive theta, I can add the two together. So if I'm adding them, 5x plus 2x, that will be 7x is equal to 38 plus 74. 38 plus 74, this is 112, is equal to 112. Such that if I divide both sides by 7, I'm going to have x is equal to 112 divided by 7. And I can use my calculator to say 112 divided by 7 is going to give me what? 16. So this is nothing but 16 degrees. So for this particular equation that we are giving, and the fact that x is taking its value between 0 and 90 degrees, this is going to be the answer to this question. And we are coming from that because of the understanding that sine theta is nothing but cos 90 minus theta. All right. In this beautiful question on measuration and triangles, we are told that in the diagram, mn is 15, mo is 3x minus 1, no is 3x plus 4, and angle omn and angle pon and angle mmp are all right angles. So we have this angle, and this angle here. They're all right angles. Our mandate is, in the first case, to even find the value of x. Looking at this particular diagram, we can say using Pythagoras theorem on the triangle MNO, this triangle MNO, because we are seeing that it's a right angle triangle with a right angle here, we can say, see, this longest side is 3x plus 4, this is 15, and this is 3x minus 1. In that case, we can have it that 3x plus 4 raised to power 2 is equal to 15 square plus 3x minus 1 raised to power 2. This is the application of Pythagoras theorem, and we are quite on track to say we want to use this. Now, there are so many ways you can say you want to go about solving it, but for me, I think if I can use difference of 2 squared, that will simplify my work. So I can say 3x plus 4 square minus 3x minus 1 square is equal to 15 square. So for difference of 2 square, that means instead of having all of this, I can just have it as 3x plus 4 minus the whole of this. But I need to put it in bracket, 3x minus 1, then multiply by, that is the difference. Now, the sum, 3x plus 4 plus 3x minus 1, this is going to give me 15 square. Okay, so this is just applying the law of difference of 2 square, that a square minus b square is a plus b multiplied by a minus b. That's what I applied in this particular line for this as a and this as b. Okay, so once we are able to do that, we can now go ahead to say we want to simplify this to say what we are now having is nothing but, look at this, this 3x and this 3x, they subtract each other. 4 minus 1 will become 4 plus 1, so that will be 5. Okay, and then in this case what we are having is 3x plus 3x, that is 6x. Okay, 4 minus 1, that is 3. This is equal to 15 square. 15 square is 15 multiplied by 15. So if I'm dividing both sides by 5, 5 here 1 and 5 here will just be 3. Even 3 can still go, but don't let me flog the horse. Let me just try and solve it now. That I have 6x plus 3 is nothing but 15 times 3, that is 45, such that 6x is 45 minus 3, and that is 42. So dividing both sides by 6, x will be nothing but 42 over 6, and that will be 42 over 6 is nothing but 7, and the unit will have to be centimeter because it is included in this centimeter. So that is the value for x. You can as well just try and say you want to expand this bracket, find it in the power of x raised to power 2. Also this one in the power of x raised to power 2. You will eventually see that we will arrive at the same answer. But working smart is quite better than just working unnecessarily hard. That's why the difference of 2 square helped us to solve this question, and we got x as 7. Okay, so that being said, I can look at a scenario now in which I'm having, since x is 7, 3x plus 4, that will be 3 times x, that's 21 plus 4. So this is actually 25 centimeters. In this particular case, 3x minus 1, 3 times x, 3 times 7 is 21, 21 minus 1. So this place is actually 20. Okay, so this is 25, this is 20. We can go ahead to say we want to find the area of triangle MNP. So let me just clear this space here now to say, now in the second part of the question, in this B part, we want to find the area of angle MNP. Okay, that's interesting now because this is actually looking like a trapezium in which you can say the area of MNPO is going to be 1 over 2 multiplied by the sum of the parallel sides, and that will be okay, how best can I label this now? Let me just call it A plus B multiplied by the height h. In this case, h is actually 15. H is 15 centimeters. All right, and then we know this. If we say this is A, that 20 is A, this A is 20, this is B, but we need to find B also because this side and this side, they are parallel. For them to say this is a right angle and this is a right angle, then this is actually parallel to this. So just leave this center first. Let's get that right, that this is A, this is B, and then 15, this is actually our H. All right, so if we have that, we can look at a means of finding B, and this is what I want us to do. In this particular lower triangle, we have all of the sides, so we can get any of the angle. Then I will notice that this particular angle, because these lines are parallel lines, ON is a transversal across those parallel lines. So this angle is also equal to this angle. So if I call this theta, this is also theta. So I can just note this is theta, right? Then I can relate the properties of triangles, trigonometric identity in this case, since we have it as 2 right angle triangles. I want something that will relate this side, which is the hypotenuse of the lower triangle, and yet it is the adjacent of the upper triangle, and yet I'm talking about theta. Okay, so let me say from triangle MNO, sine theta is opposite over hypotenuse, that is h over 25. Okay, and of course h was 15. Sine theta is 15 over 25, which is, of course, 5 can go 5. So that is 3 over 5, such that theta is arc sine 3 over 5. Can we get that? Yes, we can. So what is arc sine 3 over 5 is 0.6. This is 36.8698, or let me say 36.87. So this is 36.87. But that is not all. Also from triangle, this is what we are trying to find. It is this B. Okay, so from triangle PNO, I can say this 25 now is now the adjacent of that triangle, and this B is now the hypotenuse. So what is relating the adjacent and the hypotenuse? It is cos, because we have it as SohCahToa. So we have the adjacent, we are looking for the hypotenuse, and of course we know the angle. It is cosine that is relating that. So I can say cos theta is going to give me the adjacent, which is 25, over the hypotenuse, which is B that I'm looking for, such that B is nothing but 25 over cos 36.87, which is the value for theta. So I can take my calculator to say 25 divided by the cosine of the answer that we just got. And what's that going to give us? This is 125 over 4, or 31.25. So here I can say this is 31.25 centimeters. Now, having that, I can now use this formula for the area of this trapezium, that it is half a plus b h. H is 15, of course, that is good. A we have gotten as 20, so let me just fill in those values. A we got as 20, and now B we just got as 31.25. So with all those parameters, we can say the area of MNPO is nothing but 1 over 2 A plus B. A is 20 plus 31.25 multiplied by the height H, that is multiplied by 15. So let's put this into the calculator to say we have 0.5, to say we have 0.5 multiplied by 20 plus 31.25. I'm closing that bracket, then multiply by 15. Okay, so this is, that's 384.375. so we have 384.375 centimeters square as the area of this particular shape MNPO, which we identified to be a trapezium. And with that, we have come to the end of this beautiful journey in which we took all our time to delve into the all 13 theory questions from the WAEC November-December GCSE exam paper for the year 2021. We want to believe that this had been of benefit to you. It's going to help you to gain that excellence you are looking for, and we wish you the very best. Don't forget to like the video, to leave your comments for us to have feedback on what we are doing right, what we are doing wrong, and how best we can help you to attain that excellence that God has prepared for you. Thank you for watching up to this moment. It's DaveTuts Academy, and until next time, God bless you.